Hi everyone. So we take an example to understand the all the phases of compiler design. So what I will do here is I do not have enough space to write all the phases one by one. So I will write first the three phases, then after fourth phase here is, and the finally sixth and seventh, fifth and sixth phase here. Okay. So but you have to write this in a flow. Okay, so let's take particular this example. So I have write down x is equal to a plus b into c. Assume that it is a single program. Okay, it is a single line statement program. Generally we write hundreds of lines of codes in a particular program, but to understand the phases of compiler you have to assume that this single line is one program. Okay, x is equal to a plus b into c and then semicolon. So definitely this is a high level language program, and this high level language program is being passed through first phase of compiler, lexical analysis. Lexical analysis will consider all these variables x, a, b, c to lexemes. So basically it considers all the variables into lexemes. Okay, and it will convert this lexeme into a stream of tokens, nothing but identifier. And how it will convert this lexemes into a stream of tokens? It will use the pattern letter followed by digit. This letter followed by digit pattern is a regular expression. So regular expression I have regular expression I will cover in the theory of computation subject. So you will go through that particular subject and study regular expression and then come back to this particular example. Okay, so using this pattern, lexemes is converted to stream of tokens, means identifier. So here x is nothing but an identifier, a is nothing but an identifier, b is an identifier, and c is an identifier. So finally we get identifier equal identifier plus identifier into identifier followed by semicolon. Okay, now this particular stream of tokens is passed to syntax analysis phase. Syntax analysis phase is also called parser. The syntax analyzer phase or syntax analysis phase is also called parser, and it is one of the most important phase in compiler design. Okay, this syntax analysis phase takes the grammar which I have written here, and using this grammar it will convert the particular stream of tokens into the parse tree. Okay, so this is nothing but a parse tree. How it will convert this stream of tokens into parse tree? First you have to understand the grammar. So grammar is also discussed in theory of computation subject, but after this topic I will give you the brief definition of grammar. So grammar is nothing but a combination of variable, terminal, production and start symbol. So this grammar can be read as, carefully, this grammar can be read as a statement is nothing but identifier, assignment, expression. So E is nothing but an expression, S is the statement. So statement is identifier equal expression followed by semicolon, and expression can be expression or term, simply a term. Term can be term or a factor or simply a factor, and factor can be an identifier. So finally we have to start through a statement and go to the identifier word. Okay, so how we can convert this particular stream of tokens into grammars? First you have a statement can be identifier equal expression followed by semicolon. Then this expression has to be reduced to expression plus term. Expression can be reduced to term can be reduced to factor can be reduced to identifier. Okay, similarly term can be reduced to term into a factor, term is reduced to factor is reduced to identifier, factor is reduced to identifier. So if you traverse the particular parse tree from top to bottom and left to right, then you will get the desired expression. Okay, what is the desired expression? Identifier equal then identifier plus identifier into identifier followed by semicolon. Okay, now this parse tree is passed to the semantic analysis phase. Semantic analysis phase will convert this parse tree into a semantically verified parse tree. But here the parse tree is already verified semantically, so we do not do anything here. Semantically verified parse tree automatically achieved here. And after the semantically verified parse tree, the next phase, fourth phase, intermediate code generation. So after this phase, after the semantic analysis phase, we got semantically verified parse tree, and this semantically verified parse tree is passed to intermediate code generation. Intermediate code generation basically converts this semantically verified parse tree into 3 address code. So here the 3 lines of code is nothing but 3 address code. 3 address code. 3 address code. So in 3 address code, maximum we can use 3 addresses for any variable. So t1 equal to b into c. Basically what do here, this b into c is stored in temporary variable t1. Okay, then temporary variable t2 adds the temporary variable t1 to variable a, and finally we store the temporary variable t2 in variable x. Okay, so you have to note it down here. Maximum we can use 3 addresses for any expression given by the program. Okay, now this 3 address code is passed to the code optimization phase. Code optimization phase figure out the redundant code in the 3 address code. If any redundant code or if any useless code it will find, then it will particularly remove this redundant code and finally write the optimized code. So here the redundant code is t1 is equal to b into c. So directly we can write t1 is equal to b into c, and this particular line does not need to be write in a double. So basically it will merge these 2 lines, line number 2 and line number 3, into a single line. X is equal to a plus t1. Okay, and now finally we got the optimized code. This optimized code will pass to the target code generation. The target code generation converts the assembly language code here. So in assembly language code, the codes look like maybe jump, multiplication. So the keywords add, move, multiplication, jump, call, these are basically used in assembly language code. So what I will do here is, all the 3 variables, variable a, variable b and variable c, stored in different register. For example, variable a is stored in register r0, variable b is stored in register r1, variable c is stored in register r2, and we perform the action using these 3 registers. First we have to multiply the variable b and c. Variable b and c is stored in r1, r2. So r1 and r2 contains have to be multiplied and stored in r2 finally. Then we have to add the result. We have to add the result through a. So a is stored in register r0 and result b into c is stored in r2. Then so we have to add the result r0 and r2 and store the final result in r2, and now finally the result will be stored in variable x. Okay, so for different machines, different assembly codes will be used. Okay, this is the running example in various textbooks. Most of the textbooks will consider this example and define the various phases of compilers. Okay, so we will get through all the phases one by one in detail. First we have to consider the lexical analysis phase and talks about what are the various advantages, disadvantages of these phases and how we can use this lexical analysis phase. And after this lexical analysis phase, we will cover all the different phases in detail one by one. Okay, so in the next video we will see the lexical analysis phase.